Our sixth lecture video on momentum and collisions will cover collisions. When we are looking at collisions in one dimension, they will always follow the law of conservation of momentum. The total momentum of the objects before the collision will always equal the total momentum of the objects after the collision. As an equation, this would look like total momentum before equals total momentum after. Remember that momentum is equal to mass times velocity. If we have two separate objects that are colliding, we will call the mass of the first object m1 and the mass of the second object m2. Then we have m1 times v1 plus m2 times v2, where v1 is the velocity of the first object and v2 is the velocity of the second object. This is equal to m1 times v1 prime plus m2 times v2 prime, where the primes represent the velocity of each object after the collision. Because we are looking at velocity, you need to make sure you define which direction is positive and which direction is negative, and follow that convention throughout the problem. There are two types of collisions that we will talk about. The first type of collision is the elastic collision. In an elastic collision, two objects collide and return to their original shape without being permanently deformed. There are a couple of different ways this type of collision can occur. One object can be moving and the other object is stationary. The object that is originally moving strikes the one that is stationary. After the collision, assuming the mass of the objects is the same, the object that was originally moving is now stationary and the other object is moving in the same direction as the first with the same velocity. Again, they are only moving with the same velocity because they have the same mass. Another way an elastic collision can occur is if both objects are originally moving in opposite directions towards each other. Then the objects collide, and they essentially bounce off each other and travel in the opposite direction they came from. Again, we are assuming they have exactly the same mass in this situation. This is why that after the collision, they are moving with the same speed but opposite directions as initially. The third way an elastic collision can occur is if two objects are moving in the same direction but with a different speed. The two objects collide and then they continue moving in the same direction, but the object that was originally traveling faster is now traveling slower, and the one that was traveling slower is now traveling faster. We have to remember with all of these collisions that momentum in the system is conserved. That is why you see the velocities you see after the collision. However, in real life, there is no such thing as a truly elastic collision. Let's take a look at an example of an elastic collision. One ball with a mass of 1.05 kilograms traveling at 3.50 meters per second to the right collides with a second ball of mass 0.700 kilograms traveling at 7.50 meters per second to the left. After the collision, the heavier ball is traveling at 2.25 meters per second to the left. What is the velocity of the lighter ball? The easiest way to tackle a problem like this is to draw and label a picture first. Let's define movement to the right to be positive and movement to the left to be negative. Before the collision, we have the ball with a mass of 1.05 kilograms moving to the right at 3.50 meters per second. Then we have the ball with a mass of 0.700 kilograms moving at 7.50 meters per second to the left. After the collision, the ball with a mass of 1.05 kilograms is moving to the left at 2.25 meters per second. We want to figure out with what speed and direction is the ball with a mass of 0.700 kilograms traveling. Now that we have a clearer picture of what is going on, we can write down in a more organized format all of the data we were given. We know m1, the mass of the first ball, is 1.05 kilograms. The velocity of this ball initially is 3.50 meters per second. After the collision, the velocity of this first ball, v1 prime, is negative 2.25 meters per second. We have to make sure its velocity is negative because it is traveling in the opposite direction as it was initially, and we have defined traveling to the left to be negative. The other ball has a mass of m2, 0.700 kilograms. The initial velocity of ball 2 is negative 7.50 meters per second because initially this ball is traveling to the left. The velocity of the second ball after the collision is v2 prime, which is what we are trying to find. Since these balls are bouncing off one another, this is an elastic collision. In order to find the velocity of the second ball, momentum must be conserved in the two-ball system. So our basic equation is m1 v1 plus m2 v2 equals m1 v1 prime plus m2 v2 prime, where the primes denote the velocities after collision. Since we are trying to find the velocity of the second ball after collision, v2 prime, We can solve for this by first subtracting m1 v1 prime for both sides and then divide by m2. This gives us a working equation of v2 prime equals m1 v1 plus m2 v2 minus m1 v1 prime, all divided by m2. Now that we have our working equation, we can go ahead and substitute in our data. v2 prime is equal to 1.05 kilograms times 3.50 meters per second, plus 0.700 kilograms times negative 7.5 meters per second, minus 1.05 kilograms times negative 2.25 meters per second, all divided by 0.700 kilograms. When you go to add the three terms in the numerator together after multiplication, the first term will be positive, the second term will be negative, and the third term will be positive. Assuming everything is entered into your calculator correctly, you should get a velocity of 1.13 meters per second. Since this number is positive, that means it is traveling at 1.13 meters per second to the right, since right is positive. This concludes our discussion on elastic collisions.